it would represent very hot, like so around 10,000, 20,000, 30,000 degree temperature. So you can measure exactly what the color is, and then you can connect it to the temperature. So for example, our sun is a yellow type star, which is in the middle, which is around 6,000 degrees. Cooler stars are around 2,000 to 3,000 degrees that are red. You can also look at the same phenomenon. That's where the beauty of astronomy lies, that what we have found out about all of these things is sitting right here on Earth. And the same laws of physics that dominate here on Earth are applied over there. If you switch on your oven, or if you look at the flame, welding flame, the central part is blue. And that is because that is the hottest part. If you go out, actually it would be like in a candle. The bluest part is in the center, whereas if you go out, it's a little bit reddish in color, right? Because they are all related to temperature. So color and temperature are correlated. It's called opaque body. And so we try to figure out these directly.
So why young stars are in particular loci?
In particular?
Loci, particular pattern.
Why do they have patterns? Well, that again is... Sometimes these spiral galaxies, for example, they have stars. The reason why they are called spiral, or they look like spiral galaxies, is because new stars are forming normally in spirals. One theory is that, I mean, apart from interactions, I work on interactions, so I look at those galaxies that have probably interactions causing them. Another theory is that there is this gravitational wave, not gravitational, perturbation theory that goes in that perhaps there is a spiral density wave. Again, just like interactions produces these density waves, so can the spiral pattern. That connects it with rotation also in a way. That perhaps there are these density waves that are going in a spiral pattern. Now, wherever there is that density wave, that's where you are forming stars. But then the density wave passes. It's not the stars that move with it. The density wave passes. It's like, well, here it's far away, but if you are near an ocean, okay, there are waves. You can sit on it, and you can have a particle on top. Okay. The wave can pass through. When the wave will pass through here, the particle will go up and down. The particle doesn't move with the wave. The wave passes through. Here it's the same thing, but the density wave is here. There's a gas cloud sitting here. The density wave hits here. It's going to compress gas. It's going to form stars at this point. And then it's going to go further away. And then it's going to compress stars here and form stars. Now, these stars that we can detect, these young stars, when I say young stars, it's all relative. It's not like young meaning 10-year-old or something like that. Young meaning here, young stars live about 10 million years. Okay. So compared to our sun, for example, our sun, it has already lived for 4.5 billion years. It's going to live another 4.5 billion years. So these young stars are only 10 million years, I mean, compared to billions of years of stars' lifetime. So we are seeing a snapshot when we are talking about star formation, the places where we are looking, where new stars are forming. We are looking at a snapshot, taking a snapshot of 10 million years. Things will not change within 10 million years, but after that, it will not be the same.
So, you were going to inform about the creation of galaxies. What's the reason behind the galaxies are created?
One and connected to the other. Yeah. It's gravity. If two things come close together, then they will collide. As I mentioned before, that if two galaxies collide, stars would pass through each other because the distance between stars is much higher. And when you look at galaxies, the distance between one galaxy to another, compared to their size, is actually much smaller, relative to their size. If you normalize it, one galaxy to another galaxy is actually, in fact, it's almost considered as a plasma on a very large scale. Almost. If you can approximate those.
So you said that there's an interaction by galaxies interacting different galaxies to each other. Okay.
And gravity is doing that.
Gravity is doing this.
Gravity is doing that.
And similar is to our galaxy. Our galaxies are interacting to other galaxies.
Right.
We have any influence of these interactions.
Right. So so we know that there is one galaxy, Sagittarius dwarf, that we are disrupting right now. It's toward the Sagittarius region. But one thing that I did not mention, and I tried to mention it tonight, that is that Andromeda galaxy, the one that I showed before, that is the nearest galaxy. It's located about 2 million light years away. So when you look at that galaxy, the light has been traveling for 2 billion years, but that's the nearest galaxy. That is the only galaxy in our universe, for us, that is coming towards us. Every other galaxy is moving away from us because of, not because they don't like us, but in fact because the universe is expanding. So because of the expansion of the universe, everything else is moving away from us. Everything else is moving away from everything else also. Like it doesn't matter what galaxy you are in, you will always see galaxies moving away from us. But Andromeda galaxy is actually moving towards us. So in physics, we talk about when things move away from you in terms of light, it's redshifting. Andromeda galaxy is actually blue shifting. It's coming towards us. What's going to happen? Well, as it turns out, if we calculate the velocity of how fast it's coming towards us, in 1 billion years, Andromeda galaxy is going to be right next to us. We will start interacting with Andromeda galaxy in 1 billion years, which is not a long time. We better start preparing. Actually, it isn't, because you think that our sun is going to live for another 4.5 billion years. So we will see, we meaning if there is life here, or somewhere else, like anywhere in the galaxy, they will see this thing happen. Now, again, being here where we are located in the outer parts of our galaxy. We are located on the outskirts. Probably we will not notice any difference. Apart from for astronomers, there will be a really big galaxy really close by. So beautiful pictures. But one thing that can affect us is that once you form a lot of these stars, which would happen, there will be a lot of collisions of gaseous clouds. And you would have a lot of exploding stars. When these large stars explode, they emit a lot of radiation. So there is a possibility that there may be a lot of stars that explode near to us. And if that happens, then it could evaporate everything, or at least kill off everything from these energetic neutrinos and things like that. But other than that, nothing's going to happen. Now, Andromeda is going to pass through us, again, since those galaxies are moving towards us, they are huge galaxies, they are going to pass through us. But then, just like gravity, it's going to not go away, but come back again. Come back again. Now the orbits are going to get smaller and smaller, smaller and smaller, and eventually they're going to merge. And when two spiral galaxies merge, from numerical simulations, we find that they lose their spiral structure. Like spiral galaxies were called spiral because of their spiral structure. As it turns out, when two spiral galaxies interact or collide, this is not interact, these are collision, they will lose their spiral structure. And they'll be left off as probably an elliptical galaxy.
One more thing, you said that we are specifying the hydrogen gas here. Is it possibility of any elements, existence for any elements in galaxies?
Oh, there are all these other elements. I mean, one thing you can do is all these elements are formed in stars. Any element heavier than lithium is formed in stars, right? And so, in fact, in astronomy, we call them heavy elements or metals. Anything above lithium, we call them metals. But hydrogen is the most predominant element. It's most common. And that's where stars form. So that's why we look at hydrogen, because 75% of the universe is made up of hydrogen.
I gather there's evidence these days that many galaxies have black holes at their center. So can you tell us a little bit about the influence of the black hole and the shape? I gather it's the shape of the galaxy that gives us the evidence.
Yes. So the question is about black holes. That black holes, there is evidence that black holes exist in these galaxies. Well, first of all, let me clarify there are two types of black holes. One black hole is like a small black hole, size of our sun. If you shrink the sun to 3 kilometers, it will turn into a black hole. And so there are objects that are small black holes. These are called stellar black holes. But there are really cool black holes. So for example, there are black holes now we know at the centers of all galaxies, including our own. Those black holes that reside at the center of galaxies, those are big black holes. Those are 1 million times more massive than our sun, at least. Out to about 1 billion times. So for some galaxies, the black hole sizes are about 1 billion times the mass of our sun. And for some galaxies, it's only a million. In fact, our own galaxy has a small black hole. It's a very wimpy black hole. It's only 1 million times the mass of our sun. But for some galaxies, it's much bigger. And as it turns out, the galaxies like SA-type galaxies, which have big central regions, have big black holes. Smaller central regions like SC-SD types have smaller black holes. So in fact, our black hole, our galactic black hole, is actually a surprise, because we would have expected it to be bigger, but in fact it's really small. Now the question comes in, when galaxies collide, what happens to these black holes? We expect, actually we've seen some of these evidence, that these black holes also collide eventually. Again, they both go initially in orbit, and again, just like galaxies, they would spin and then they would merge together to form a bigger black hole. Because you can always increase mass to a black hole. You can always throw stuff in. It's going to just bigger and bigger. So you form these black holes. And yes, any question? Oh, and so the next question comes in, like, where do these black holes come from? And just like everything else in the universe, there are two theories for that. One is that these black holes were left over from the Big Bang. When the universe was formed, they were left over. These were primordial seeds that were left over, and galaxies formed around them. They were the ones that captured gases around them and formed galaxies. So now we find black holes in the center. It's not surprising, because that's how galaxies were formed. And the other theory is that in the central region, as I mentioned, these are very high density regions. The stars are much more dense in the central regions. And perhaps there were so many dense stars in there that they formed a lot of dead stars, neutron stars, and small black holes, and they all merged together over a period of time to form a big black hole. So you form galaxy first and then a black hole in the center, because the density of stars is much higher in the center than on the outside. So those are two competing theories. It's so far, really, there isn't one way or the other. It's very difficult to say what is the right theory. But we definitely know that stars collapse. If you have a cluster of stars, they do collapse. So from that angle, that is more consistent.
I'm also keeping with a new question. That how are you collaborating or interacting with Pakistani astronomers? What is the sort of economy of Pakistan?
Those interactions are different from these galaxies. But one of the problems is that there are very few Pakistanis, even in the US. So I try to maintain a list of who is there. So I have a website on which I have a list of people who are on the amateur societies in Pakistan, and also astronomers. Now, the fact that there are so few Pakistanis makes it a problem, because we all work in different areas. So I work in galaxies. There's another Pakistani who works on stars. There's another Pakistani who works on the universe. We cover everything. And then there's one Pakistani who works on numerical simulations. And so far, there hasn't been any collaboration amongst Pakistanis.
But this is Pakistani outside.
These are Pakistani outside.
I'm talking about Pakistan.
Pakistani inside. So far, there hasn't been any collaboration. That's
there are no Pakistanis inside.
Actually, we're very honest.
So that's the point which I wanted to bring up. That's still Pakistan.
I should clarify. If you can give me a second, I would like to clarify on that. One thing is that now a lot of this data, I mean, apart from going to the telescope, a lot of, like Hubble Space Telescope data, that is available publicly online. I mean, you can get the same data that astronomers are getting for Hubble Space Telescope, for Chandra, for any new, in fact, almost all new telescopes. There is a big telescope that just went up called CERDIF, Space Infrared Telescope Facility. It's just like Chandra, it's just like Hubble, but in the infrared. It will not have any proprietary time. As soon as they take the data, it's going to be public. So in a way, if you want to access data, you can get that. So from Pakistan, work can be done. It's all you need is a good computer, because you need to get data from, and a connection, because you can get data from there and then you can work on that. So it's possible.
I think it's a good point to thank our speaker. He has been speaking for the last 75 minutes. So if you have any further questions, we can keep it tonight. So let us give him a big hand. Thank you. Now, I would like to invite our chief guest, Dr. Hassan Shah, to give his comments on this activity and seminar.
Thank you very much, Dr. Salman Hameed. I'm not really used to being know. But anyway, I think it's been a wonderful lecture, and I think we've all learned and enjoyed a lot today. Dr. Hassan Hameed started right from the beginning. I think it was a very good introduction to astronomy, talking about the work of Hubble and the classification scheme that he came up with, and the difficulties which were initially faced, how measurements were made, how this two-dimensional sky that we see is actually, as we know it is three-dimensional, but how these measurements are made, and these Saffir variable stars. I think we got introduced to a lot of new terminology. Maybe most of us were not really familiar with these things. For example, I was not very familiar with how these things are done, but at least it's left us with some idea about how these measurements are made in space. And as he pointed out, that any